Hello everyone, today I want to explain my homework 5, homework 1. Write a 3 language to control piston with timer and counter and show flash them together. First, let's look at the crew learning and implement goals of this homework. There are 5 points. First, master the logical convention and practical implementation of 3 PLC programming languages: render diagram, function block diagram, and structure text. Second, use set and reset instruction to switch the working state of the piston. Third, and the No.1 delay timer to realize delay control and optimize the action timing of the piston. First, build a fundamental circuit to check if the PLC program and the physical model work together correctly. Fifth, make the timer completion cycle trigger the counter and lock the whole control logical after 3 cycles to stop the system circle action. These 5 points are also the crew content I finished this homework. Next is the crew requirement of this homework. The control logical requirement of the piston, which is mainly divided into 3 parts: trigger condition, action process, and the reset function. First, the trigger condition: the piston control system will start only when the start signal start and the internal limit switch S0 are wielded at the same time. Second, the action process after the system starts. The solid valve Y1 is analyzed and the piston extends. When the piston is fully extended, it triggers the limit switch S1. Then the timer starts a 5-second delay. After the delay, the solid valve Y2 is energized and the piston retracts. Third, the reset function. When the reset signal is triggered, both Y1 and Y2 are de-energized. The whole system returns to the internal state directly, and the piston stops all actions. To control the piston, we first need to master the core characters of 3 PLC programming languages, which are also the core knowledge points of this homework. The first is render diagram, LD for short. It is a graphical programming language that simulates the traditional relay control circuit. Its logical is intuitive and it is very suitable for electronic engineers. The second is function block diagram, FBD for short. It uses model design and realize logical operation through the combination of function block, which is intuitive and effective to operate. The third is structured text, ST for short. Its grammar is similar to high-level programming languages. It has a strong logical expressing ability and is suitable for writing complex control logical and other terms. Next, I will use these three languages to realize the piston control logical respectively. This is LD. This page is a specific implementation logical of Lender diagram. I designed 5 runs in total, and each run realized a curl function. Run 1. Connect the start single start. The inteto limit switch A0 and the NOT output single of counter 1. In serials to set Y1 and reset Y2, which is the control of piston extents, and run 2 connect the limit switch A1 in serials or to trigger time 1 to start timing, and the present time PT of the timer is set to 5 seconds. Run 3. Connect the completion single of timer 1 in series to reset Y1 and set Y2, which is the control of piston retraction. Run 4. Connect A0 and the NOT single of Y1 in series of reset Y2 and make the piston stop retract. Ring 5. Connect the completion single of timer 1 in series to trigger counter 1 to start counting, and the percent value PV of the counter is set to 3. The whole Lender diagram fully realizes the control of piston extension, retraction, delay, and counting through the series logical of runs. This is the function block diagram. FBD realized control through the combination of function blocks and logical gates. I defined several curl function blocks: SR, set, and reset block, TON timer block, and CTU up counter block. First, extension trigger. The start circle start A0 and the NOT output single of CNT are connected to the set and of SRI1, the set and reset block of Y1, through an AND gate, making Y1 and the piston extend. Second, timer control. A1 is connected to the input end of the TON timer TT with a percent time of 5 seconds. After timer is completed, the output of TT is 1, which sets SRY1 and sets SRY2, the set and reset block of Y2 at the same time, making the piston retract. Third, retraction stop. A0 and the NOT single of Y1 are connected to the reset end of SRY2 through an AND gate, making Y2 0 and the piston stop retracting. First, counting logical. The complete completion single of TT is connected to the CU end of CNT. The persert value of the counter is 3. After 3 counts, the output of CNT is 1, which locks the system and stops new exertance cycles. The modular design of FBD makes the correlation of the whole logical very clearly. This page is the implementation logical of instruction text. ST is white in statement from similar to high-level programming languages. I first defined the No.1 timer 1, CPU counter 1, and the time variable my time as global variable. The specific logical is divided into 5 parts. First, extension logical. So the if conditional statement when start and zero are valid and counter 1 has no output, set y1 to true and y2 to false. And the piston extends. Second, timer call timer 1 use A1 as the input, 5 seconds as a percent time, and store the timer value in my time. Third, retraction logical. So the if conditional statement when timer 1 finishes timing, set y1 to false and y2 to true, and the piston retarget force retardation stops. So the if conditional statement when A0 is valid and y1 is false, set y2 to false and the piston stops retracting. Fifth, counter call counter 1 use the completion single of terminal 1 as the up count input, set the set and to false and the percent value to 3. The logical is locked after 3 counts. The statement-based writing of ST make a complex logical judgment and function call more concise. After writing the PLC programs in 3 languages, I built a fundamental circuit with floor sim software and finished the virtual simulation verifications. The crow composition of this fundamental circuit is divided into 4 parts. First, air supply part, including compressed air source and pressure regulating valve, which provides stable air pressure for the whole fundamental system. Second, actor, use a double acting cylinder to directly control the acceptance and the retraction of the piston. Third, the control elements use 25 or 2V soldered valves corresponding to Y1 and Y2 in the PLC program, which receive the PLC output signals to switch the air circuit. First, detection elements install 2 magneto limit switches corresponding to S0 and S1, which set the piston position signals to the digital input parts of the PLC to realize closed loop control. With this automatic circuit, I successfully verified that the PLC program and the physical model work together correctly. The above is the full information process of this homework. Next, I will summarize the completion of this homework. First, completion steps. I successfully used 3 PLC programmer language LD, FBD, ST to realize piston control with a timer and a counter, and finished the flow stem simulation verification. Second, logical concision. The core control logic of the 3 programming languages is completely the same, only the expression forms are different: graphical, modal, and textful. This reflects the complexity of PLC programming languages. Third, simulation value. FlowSim software intuitively verifies the linkage effect of the PLC program and the automatic system, which avoid the risk of physical hardware. Debugging and improves the debugging efficiency. Fourth, key points in the whole control logical design. The interlock design of saucer Vivo Y1 and Y2, and the automation of the timer trigger condition as the core to ensure the stable operation of the system and avoid action conflicts. Finally, I built an experimental platform with actor PLC hardware and photomatic components, and finished the physical demo of the piston control. The effect of physical demo is actually the same as the result of PLC program design and FlowSim simulation, which prove that the control logic designed in this homework is correctly and feasible. That's all of my report. Let's look at this video. That's it, all my homework 5.1. Thanks for your listening. See you.